Good morning to everyone. We just completed the installation of Ballast Water Treatment System or BWTS. So from design, installation, commissioning, operation, water sampling, and ship crew training in a Philippine Shipyard. So this is now the complete installation of BWTS from our existing ballast line. We add the ballast water treatment system pipelines and also the equipment. We have here the filter, the valves. These are additional installation for the ballast water treatment system. So first we go with the 3D design. So from our existing ballast line, we add the additional pipelines and also the equipment. The filter is F100 and filter is F101, and also all other equipment that are needed for the injection of chemical using electrolyzer. And we have also by control system, we have the BWTS control panel. So this is now our design, and then we proceed also with the design using the 3D and isometric. So from the existing pipelines, we add this we add the additional pipelines for ballast water treatment system, including all the valves and also the equipment, that is the filter. We have the flow meter. So we have to follow this during installation as per drawing. But here we have also the adjusting pipe. You've seen the red pipelines. So even though the design is almost perfect, but during fabrication of this pipeline, there are some adjustment that we need, especially during installation. Okay, so this adjusting pipeline will do the adjustment on site. So we have here the 2D and production drawing. So for example, this adjusting pipe. So this adjusting pipe is not fully welded. It's only tack weld. So we have plus 100. So either we need to cut some of the pipe in order to adjust during installation. So this is the one example, the adjusting pipe. And we have also the electrical and connection diagram. So this system is almost fully automatic. So we need the electrical installation, connection, and also for the program, software automation. So during pipe installation, as we have discussed, we need some adjustment. Okay, so some equipment are offset, are not aligned. So we need to adjust this location. So same, we have from the starboard side, we have also on the port side. There are some adjustment. The flanges are not properly aligned, so we need to adjust them. So same problem, but the shipyard is able to adjust. So after all the installation of the pipe, the valves, of all the equipment for ballast water treatment system, we have to check that it is according to the design and to the maker's standard. So for example, we have here the filter inlet. So this filter inlet is coming from our ballast pump. So we pump it from the sea, and then we need to filter it, and then we need also the filter outlet. This is going to your ballast tank. Okay, but before going to ballast tank, in order to fully treat the seawater, we need a disinfectant. This is to kill the microorganism. The small organism need to be treated, need to be killed using disinfectant. Okay, so during ballasting, this is from the filter outlet. So this is going to ballast tank. So in order that the seawater going to ballast tank is fully treated, we need the filtration and also the chemical disinfectant. This is during ballasting. And during deballasting, in order that the seawater will not affect the seawater, the sea. So this disinfectant is a little bit strong. The chemical is strong. So we need a neutralizer. Neutralizer in order that the seawater that is going to the overboard will be treated. Okay, it will not affect the living organism in the seawater. So this disinfectant with high chemical, so we have to induce neutralizer. And then after the piping installation, we need also the electrical installation. So we need all those PLC that are bulbs that are needed to be automated. So we need this electrical installation. As per drawing, we have to follow them. Check and follow them, and then we check them. So after all the installation, we already have the piping and also the electrical. So we need to run the pump test that there are no leakages on the pipeline, and then we need to run the pump on minimum speed and then also in maximum speed in order to check the leakage and also the vibration. So if there are some vibration during the operation, so we need to add more pipe support in order to prevent the pipe vibration. And also we have also, as per maker's recommendation and standard, TRO sampling must be installed on horizontal pipes. This vertical pipe sampling is no good. Okay, vertical pipes, if you do sampling on the vertical pipes, there will be some abnormalities with the system. It will not take proper water. So we need, as per maker's recommendation, we need to install it on a horizontal pipe. So this is the horizontal pipe. So sampling is better. TRO sampling is better on horizontal pipes. And after all the installation, we proceed with the maker's commissioning. So makers have some setting. TRO setting, filling of neutralizer, control valve setting, and all equipment need some setting. So after the setting, the maker is going to do the ballasting operation. So maker have to test it using number 1 ballast pump, also number 2 ballast pump, and also together number 1 and number 2 ballast pump. That is during ballasting. So as per maker's recommendation, the TRO should be 2.5 to 3.0. That is during ballasting. And during deballasting, so we need to run the ballast pump, number 1, number 2, sleeping, and after peak tank. So as per IMO requirement and USCG requirement, the TRO must be less than 0.1 ppm. Okay, so this is the requirement with IMO and USCG. So during the operation, we check. We have here all the data, and we also check on the local side if all the equipment are properly operating. Also checking on the control panel. So after installation and then maker's commissioning, so when everything is properly operating, we do now the water sampling. So as per requirement, it must be less than 10 organisms per cubic meter. So we do the water sampling that there are no dangerous organism that is inside your ballast tank. So we check the analysis. We have the L size and the S size analysis. So it all pass. That is the risk is low. So it is less than 10 organisms per cubic meter. Okay, and lastly, when everything is normally operating with the maker, we have to pass it to the ship screw. So we need the ship screw training. So the valve operation. So this valve, they already have the ballasting, and then additionally, we have also the ballast water treatment system. So they can operate the valve from 0% to 100%. So it depends on the flow rate that you need during ballasting. And also, the ship's crew must be able to know how to use the remote control panel in the ship's office. So they must know during ballasting and also deballasting, and which valve to open and which valve to close. So all these have to be passed to the ship's crew. So also on the local side, the ship's crew have to understand the TRO, the setting, the maintenance, and also the location of the valve to open and close. So all the equipment you have to check during operation that everything is normally operating. Valves shall be open and shut, whichever operation, ballasting or deballasting. So for the following services, please contact us. 3D design and production drawings. So we are a design company, and we do also commissioning and after service, and also for installation and supervision job. So we will be waiting for you if you need our services, and please contact us. Thank you.